Hi everybody. This section is about graphical misrepresentation of data, and so we're really only going to have one objective in this section. This is describe what can make a graph misleading or deceptive. Um, so, um, so what can make a graph misleading or descriptive? Um, so before we look at this, let's look at a definition here. Statistics is the only science that enables different experts using the same figures to draw different conclusions. Or there's another famous quote that says, there's lies, damnable lies in statistics, meaning that, I guess even though statistics is based on numbers and facts, you can look at things in different ways and draw different conclusions or manipulate the way that you look at the data to get different answers. So let's look at some examples in this section. So the data in this table represents the historical life expectancies, basically the number of years people lived of people in the United States. And we want to construct a misleading time series graph that implies life expectancies have risen sharply, and then B, construct a time series graph that is not misleading. So here's the life expectancy in years of some the information. You can see here it grows pretty steeply, so you might think, well, people are living a lot longer than they used to be based on this graph. But you can also construct another graph where, again, the graph goes from 0 to 80 instead of 68 to 78, and you can see here that it might not seem like people are living that much longer if you look at this graph, right? So again, this graph could be misleading because it doesn't start at 0. Here's another example. Let's say the National Survey of Student Engagement asks first-year students at college, right, how much time they spend studying or getting ready for class each week. And the results will be summarized in the next slide here. And so we can construct a pie chart that exaggerates the percentage of students who spend between 6 and 10 hours, and then construct a pie chart that's not misleading. So here's the data. So that means that about 13% of students study between 1 and 5 hours, 25% of students study between 6 and 10 hours. So here's the pie chart. Now this might be misleading because this is sort of three-dimensional and this part is sticking out at you. So it might seem like this part is really big compared to others. And maybe it is. But if you look at it from the top, right, you might see that this piece here is just about as big as this. So again, having pie charts at an angle can be misleading. Couple guidelines for constructing good graphs. Title and label the graphic axes clearly, provide explanations if needed, include units of measure, and a data source when appropriate. Avoid distortion, right? Never try to mislead or lie about data if you can. I mean, sometimes people are pressured to lie about data. I remember seeing this TV show called Tech TV. This was back during the tech boom, but it was hosted by this guy, Leo Laporte, who I think hosts a radio show now. But they interviewed people from the computer industry, and they had some people from Amazon.com on, and apparently the guy's boss always told them to make graphs go up and to the right, and so apparently they were somehow misleading the CEOs and the corporate board of Amazon somehow, because apparently the profits were not going up into the right, or at least not up into the right as quickly as they thought. Minimize the amount of white space in the graph and use the available space to let data stand out. If scales are truncated or cut off, like we saw in that example with life expectancies, be sure to clearly indicate that to the reader. Avoid clutter and backgrounds and pictures don't distract the reader. Avoid 3 dimensions if possible. Three-dimensional charts might look nice, but they might lead to misrepresentation of the data, like we saw in that pie chart. Don't use more than one design in the same graphic. Again, sometimes graphics can look out of proportion. There's a little book that's called How to Lie with Statistics, and they give other examples in there. I don't know if you can find that online or not. And I'm not suggesting that you have to read it, but that has lots of good examples. and avoid relatives graphs that are devoid of data or scales. So graphs that compare one thing to another without data or scales. So I just wanted to let everybody know too that there is in the discussion board there is a extra credit question related to this section. If you guys want to go ahead and take a look at that and comment on that, I will give you guys some extra credit points, and that will be open until the end of the semester. So if you guys have any questions or concerns about that or anything else, just let me know.